Hi student, welcome to my YouTube channel. Today, on the request of class 12 student, we solve some problem on applications of derivative. That is mathematics part second. And in this mathematics part second, chapter number second is applications of derivative. And in this chapter, most important units are: first is related rates, second is increasing and decreasing function, and third is maxima and minima. So today we solve one problem on related rates. But right here one word problem on the board. This is one important problem and important unit. So first I read here the problem. This is word problem. The volume of spherical ball is increasing at the rate of 4 pi cc per second. The volume of spherical ball is increasing at the rate of 4 pi cc per second. Find its rates and which the radius and the surface area changing when the volume is 288 pi cc. That is, here we find the rates at which the radius and the surface area are changing. So suppose in this problem we assume that let V be the volume of the spherical ball, R be the radius, and capital S be the surface area of the spherical ball. So we write here, let V be the volume of spherical ball, R be the radius, of spherical ball, capital S be the surface area of spherical ball. Next we write here given. It is given that the volume of spherical ball is increasing at the rate of 4 pi cc per second. That is, here the rate of change of volume with respect to time means here dv by dt is given. Again understand this, that is, volume of spherical ball is increasing at the rate of 4 pi cc per second. That is, here the rate of change of volume with respect to time t, since it is given that dv by dt, that is the rate of change of volume with respect to time t, is given. This is 4 pi cc per second. This is given. Next, again it is given that volume, again it is given that volume, that is the volume of the spherical ball, that is V is given. So again we write here V, that is the volume, which is equals to 288 pi cc. Then by focus, that is, what can you find? So here we find it rates at which the radius and the surface area are changing. Means here we find dr by dt, that is the rate of change of radius with respect to time t, and surface area. So here the surface area is denoted by capital S. So we find here the rate of change of surface area with respect to time t, that is, we find ds by dt. So we write here to find dr by dt is equals to what? And ds by dt is equals to what? That is, here we find rate of change of radius with respect to time, and rate of surface area, rate of change of surface area with respect to time t. So next we write here, we know that since the formula for finding out the volume of sphere, we know that the formula in 10th standard, we know that the formula for finding out the sphere, that is the volume of the sphere, V is equals to 4 by 3 pi r cube, that is radius cube. This is the formula for finding out the volume of the spherical ball. V is equals to 4 by 3 pi r cube. Next, differentiate this volume V with respect to t. Then we get rate of change of volume with respect to time t. So here differentiate both sides with respect to t, with respect to t. Then we get here dv by dt, which is equals to 4 by 3 pi constant d by dt of r cube, because here radius is not constant, radius is changes, radius is changes, so here radius is variable, so we differentiate the radius r with respect to time t. Therefore here dv by dt is equals to dv by dt is equals to 4 by 3 pi, this 4 by 3 pi as it is. And next we find d by dt of r cube. We use here the formula ddx of fx to the power n, n fx to the power n minus 1 into f dash of x. Similarly here into this 3 r to the power 3 minus 1, that is r square into dr by dt, that is differentiate radius r with respect to time t. Because here we use the formula ddx of fx to the power n, n fx to the power n minus 1 into f dash of x. Then here this 3 get cancelled, 3 get cancelled. dv by dt, that is the rate of change of volume with respect to t, and this is given. See here, dv by dt is equals to 4 pi cc per second, 4 pi cc per second. So we write here 4 pi, which is equals to 4 pi, here dv by dt, and dv by dt is given, that is 4 pi. Here 3 get cancelled, then remaining 4 pi r square into dr by dt as it is, into dr by dt as it is. Then this 4 pi get cancelled, 4 pi get cancelled, that is divided both sides by 4 pi. Therefore 1 is equals to r square into dr by dt, 1 is equals to r square into dr by dt. Then from this we find dr by dt. Therefore from this dr by dt, which is equals to 1 upon r square, dr by dt, which is equals to 1 by r square. That is, here we find the rate of change of radius with respect to time t. Here we find rate of change of radius with respect to time t. Next here volume is also given, that is V is equals to 288 pi cc. By put here volume and find out the radius. We put here volume and find out the radius. So suppose here I assume that this is the equation number first. Equation number first. Next we put here V. V is equals to, it is given that V is equals to 288 pi. So we write here 288 pi, which is equals to 4 by 3 pi r cube. In the formula of volume, we put V is equals to 288 and find out the radius of the spherical ball. First we find here the radius of the spherical ball. Then here this pi get cancelled, that is divided both sides by pi, then pi get cancelled. Next here 4 ones are 1, 4 sevens are 28, 4 ones are 1, 4 twos are 8. That is 288 divided by 4, so we get here 72. So we get here 72. Therefore here from this we find r cube is equals to this 72 as it is multiplied by 3. Again we repeat this r cube which is equals to 72 as it is multiplied by this 3. So 72 into 3. Then after multiplications we get here therefore from this r cube is equals to 3 into 2 6, so write here 6, then 3 into 7 21, so write here 21. Then 216 can be written as that is here r cube is equals to 216, and from this we find here the value of radius r. So here 216 can be written as, suppose here we write say 8 into 8 64 into 8 6 into 6 multiplied by 6. So 216 can be written as 6 cube. 216 can be written as 6 cube because here 6 into 6 36 and 36 multiplied by 6, so we get 216. Therefore 216 can be written as 6 cube. So we write here r cube which is equals to 6 cube. Then we equate the base, therefore radius of spherical ball which is equals to 6. Radius of spherical ball which is equals to 6. Then we put the value of radius of spherical ball in equation number first. We get rate of change of radius with respect to time t. Therefore here dr by dt put in equation first. Therefore dr by dt which is equals to 1 upon r is here 6, so 6 square is equals to 1 upon 6 square, that is 36. Therefore rate of change of radius of spherical ball with respect to time t which is equals to 1 by 36 cc per second. This is the rate of change of with respect to with respect to time t, which is equals to 1 upon 36. We find here rate at which the radius changes. Means here we find dr by dt, and dr by dt is equals to 1 by 36 cc per second. Next we find the rate at which the surface area changes. Next we find the rate at which the surface area changes. And we already assume that capital S be the surface area of the spherical ball. Then we find here ds by dt. And we know that the area of sphere, which is equals to, that is 4 pi r square. So we write here surface area of sphere or spherical ball, capital S, which is equals to 4 pi r square. This is the formula for finding out the surface area of the spherical ball. Then differentiate this with respect to time t. Differentiate both sides with respect to t. So we get here ds by dt, which is equals to 4 pi constant d by dt of r square. Therefore ds by dt, which is equals to 4 pi into d by dt of r square. Again we use the formula ddx of fx to the power n fx to the power n minus 1 into f dash of x. Therefore here 2 into r into dr by dt into dr by dt. Again we repeat this. Our aim is to find out the rate of change of surface area of the spherical ball with respect to time t. That is, here we find ds by dt, and we find this from the formula. We know that the formula surface area of spherical ball, which is equals to, that is 4 pi r square. Therefore ds by dt, which is equals to 4 into 2, so write here 8 pi as it is into r, that is the radius of the spherical ball, and we already find the radius is 6, so write here 6 into dr by dt. We find here dr by dt 1 by 36, so we write here 1 by 36. Again we repeat this, ds by dt, which is equals to 4 into 2, 8 pi as it is, then r, that is the radius of the spherical ball, radius is here, r is equals to 6, so we write here 6 into dr by dt, that is the rate of change of radius with respect to time t, 1 by 36, so we write here 1 by 36. Then here 6 ones are 1, 6 6 are 36, 6 6 are 36, 2 4s are 8, 2 3s are 6. Therefore here ds by dt, which is equals to, here 4 by 3 pi centimeters cube per second. And this is the surface area, that is the rate of change of surface area of spherical ball with respect to time t. Means in this problem, this is word problem, this is one important problem. यानी बोर्ड की जो एग्जाम है वो एग्जाम के अंदर आपको 3 या 4 मार्क्स के लिए आ सकता है, सेक्शन सी और सेक्शन डी के अंदर ये प्रॉब्लम यानी आ सकता। सो सिंपल प्रॉब्लम है। ये प्रॉब्लम के अंदर आपको क्या है, the volume of the spherical ball is increasing at the rate of 4 pi cc per second, that is here dv by dt is given, dv by dt is equals to 4 pi. Next here find it rates at which the radius and surface area changes, means we find radius, suppose capital R, so dr by dt. Next we find surface area, say capital S, then we find ds by dt, and here volume is given, that is 288 pi cc. So in this problem we use two important results. First, we know that the volume of formula for finding out the volume of the spherical ball, that is V is equals to 4 by 3 pi r cube, and surface area of the spherical ball, that is S is equals to 4 pi r square. If I remember these two results, then easily we solve the problem. Okay, thanks.